So in this video, I'll go through an example on node voltage using KCL, because when current sources are involved, you have to use some current sources. KCL. And I did an example where I kind of showed how to solve the node voltage using KVL. So it just depends on what the circuit is made up of, which determines like how to solve. So again, I have this circuit here. Current here just indicates the direction of current, so 8 amp flowing this way. Then I have another current source, so I have some resistors. So you go through, can identify the nodes. So here's one node, two, and I have my reference. You always have to have a reference, because especially when you measure or calculate voltages, it's always from one point to another point, so it's a difference. So if I do a KCL at junction 1, which is this one here, now, and I'm going to take current going in as negative, current going away from, because if you see 8 amp is going in, I'm going to take this current going this direction. This is just an arbitrary. Unless it's a source, then I show the actual direction. So I'm going to sum up all those currents, keeping in mind that if current is going away is positive, it's just an arbitrary choice. You know, you don't have to do it this way. You just have to be consistent. Current going in has to be opposite from current going out or away from the junction or the node. So then if you do KCL at 1, so I have 8, so negative 8 because it's going into the node, plus 1 amp because this current here is going away, plus 110 or I10. And what is I10? It's flowing in this direction, plus I12. So I got this current, I got this one, I got this one, so I just need this one. So the sum should be equal to 0. Then so this here, the sum is just negative 7 plus I10. So 10 is from this point to this point. That's just plus V1 divided by 3 ohms. Ohm's law, basically. I12 is V1 minus V2 divided by 6 ohms. I'm just doing Ohm's law. So this here is this Ohm's law, and this one is this one. So it's equal to 0. Then if I simplify, I'll get something like 1/2 times V1 minus 1 over 6 times V2 is equal to 7. So I wrote them in terms of V1 and V2 because those are the unknown. So we can call that equation 1. So if I go here, so I have one equation, but I have two unknowns. I need another equation, then I can solve it. So now let's do another KCL at node number 2, which is this one here. So again, current away, I'm going to take that as positive. So then this current here is going in, so it will be negative. So negative 1 plus V2 minus V1 divided by 6 plus V2 0, or if it's just V2 divided by 10 plus V2 divided by 15 equal to 0. In other words, I start from this current here because this 1 amp is going into junction 1, so it's negative. It's just by choice. I chose that current in as negative, current away as positive. It's just my choice. You can choose the other way around. You just have to be consistent. Then I said, then this current here. So I got this current. Now I'm going to do this current, which is V2 minus V1 divided by the resistance, which is 6 ohms. So I got that. Then I got from this point to this point V2 minus V0, which is just V2 divided by 10 ohms. Then from this point to this point, V2 divided by 15. So again, if I simplify, I will get something like -1 divided by 6 times V1 plus 1 divided by 3 times V2 equal to 1. So that's equation 2. Now you just plug it in the calculator or MATLAB or whatever you're using, or you can solve it by hand, like solving for V1 in terms of V2, then you plug that in the other equation and you solve for V1, then you plug that value in the other equation to get V2. So if you solve, basically you will get V1 equal to 18 volts and V2 equal to 12 volts. So the main thing is just writing the proper KCL equations, you know, keeping in mind, being consistent. Whatever you take as current in, if you take it as negative, you have to do that for all of the ones that are going into the node. And the ones that are positive, you take them as positive, so you just have to be consistent. Otherwise, you're gonna mix negative and positive, and then your results will be incorrect. Thank you.